This is the video for 9.1, and we are talking about quadratic functions. A quadratic function is any function that can be written in the form y equals ax squared plus bx plus c. And that is standard form of a quadratic function. Remember what a parent function is. It is the simplest form of any function that's in a function family. So the quadratic parent function is y equals x squared. That is the simplest form of a quadratic function. A parabola is the curve that results from graphing a quadratic function. And the axis of symmetry is the imaginary line that cuts the parabola into two equal parts. The vertex is the highest or the lowest part of the parabola. A minimum is when the vertex is at the lowest point of the parabola, and that occurs when a is positive. When a is greater than 0, the graph opens up and we have a minimum. But when a is less than 0, the graph opens down and we have a maximum. So a maximum is when the vertex is at the highest point of the parabola, and that occurs when a is negative. So if I was to ask you to draw me a parabola with a maximum vertex at 0, 3, this is what you would do. First, go ahead and graph a point at 0, 3. That is your vertex. Then it says the vertex is a maximum. So that means the graph opens down. The vertex is at the highest part of the parabola. So now go ahead and hit pause and draw me a parabola with a minimum vertex at 1, -1. And this is an example of a parabola with a minimum vertex at 1, -1. The graph is going to open up, so the vertex is at the lowest point of the parabola. Example number 2. Graph y equals 1/3 x squared. What is the domain and what is the range? So right now, this is how I want you to do this. Come up with some values for x, plug them into the equation, and determine the corresponding value for y. Always pick 0, and then come up with 2 positive values for x and 2 negative. And pick numbers that are mathematically easy to work with. So now notice here, my denominator is 3. So I wanted to pick values for x that would be mathematically simple given the fact that my denominator here is 3. So what's the domain and what's the range? Well, my domain, remember, is all of my possible x values, and the range are all of the possible y values. So the domain here is going to be all real numbers, because remember, this graph is going to keep going out in both directions towards infinity. So it would eventually hit all possible values for x. This graph would eventually cover all values of x. So the domain is going to be all real numbers. The range, however, is y is greater than or equal to 0, because all of the possible values for y, or all of the possible values of y for this function, are going to be greater than or equal to 0. Okay, so now go ahead and hit pause and graph y equals negative 3x squared and identify what is the domain and what is the range. So here's the graph. Again, I want to pick values for x that are easy to work with, so I picked 1s and 2s here. The domain is going to be all real numbers because, again, this graph is going to keep going out in both directions towards infinity, so it would eventually cover all possible values of x. However, my range is y is less than or equal to 0. The y values for this graph are going to be all values of y that are less than or equal to 0. Now, how does this graph differ from the one above it? Well, notice the one above it, the first one that we graphed, is faced up. This right here is faced up. However, this graph is facing down. Because remember what we said about A. When A is positive, the graph is going to face up, and when A is negative, the graph is going to face down. Now I want you to go ahead and I want you to hit pause and I want you to graph both of these. Graph both of these functions and identify what is the domain and what is the range. Create a table of values for both of these. So here is the graph for the first one. My domain is all real numbers, but my range is y is greater than or equal to 3. Why? What happened here? Notice the graph is shifted up 3 units. The vertex is shifted up 3 units. Now let's look at this one. The domain, again, is all real numbers. But here, the range is y is greater than or equal to negative 3. And again, look at what happened here. Here, my graph is shifted down 3 units. The vertex is shifted down 3 units. Now, before we go to the last example, let's review straight lines. So I graphed the parent function of a straight line. That's the black dotted line, y equals x. And then I graphed y equals 1/3 x. What did I do? I changed the slope from 1 to 1/3. And when I did so, what happened? The line is actually getting closer to the x-axis. Well, now let's look at this one. Again, I graphed the parent function, and then I graphed y equals 3x. What did I do? I changed the slope from 1 to 3. And when I did so, what happened? The line is getting further away from the x-axis. Well, the same thing happens with quadratic functions. So I graphed the parent function y equals x squared, that is the black dotted line, and then I graphed y equals 1/3 x squared. What did I do? I changed a from 1 to 1/3. And what happened when I did that? The graph is getting closer to the x-axis. We call that a vertical compression, and that happens when the absolute value of A is greater than 0 and less than 1. Now, the book says the graph is getting wider, and right now you can think of it like that. But when the graph is getting closer to the x-axis, we call that a vertical compression. Now notice I said the absolute value of A, because remember, the positive and negative sign of A only tells us if the graph is opening up or down. So if A is positive, the graph is opening up. If A is negative, the graph is opening down. The sign of A, whether A is positive or negative, has absolutely nothing to do with the width of the graph. When you're talking about how narrow the graph is or how wide the graph is, you're only looking at the absolute value of A. So now look at this example. I graphed the parent function, again, that's the black dotted line, and then I graphed y equals 3x squared. What did I do? I changed A from 1 to 3. And what happened when I did that? Now the graph is getting further away from the x-axis. So we call that a vertical stretch. When the graph is getting further away from the x-axis, we call that a vertical stretch. And that happens when the absolute value of A is greater than 1. And the book says the graph is getting more narrow. And again, that's fine. Right now, you can think of it like that. But when the graph is getting further away from the x-axis, we say that there is a vertical stretch. So now look at example number 4. Compare the widths of the graphs. So you can think of it like this. The larger the absolute value of A, the more narrow the graph is going to be. So this is your parent function. So this right here is going to be your widest graph. And this is going to be your most narrow. Remember, this negative sign tells us that the graph is going to open down, but it doesn't have anything to do with how wide or how narrow the graph is going to be. Okay, so now go ahead and hit pause and go ahead and compare the widths of these graphs. So this graph right here is going to be my most narrow, and this one is going to be the widest.